Inverses. When you guys solved for inverses in the past, what was the process to solve for an inverse?
X and Y switch.
Switch X and Y and then what? Resolve. So if you had a problem where it was Y equals 2X minus 1, you're going to find the inverse of that.
X equals to Y minus 1.
Yeah.
Thanks, bud.
And then you resolve for Y. You guys vaguely remember that?
Yeah.
Yes, ma'am. Still part of 8-4, like I said. There's too much material in 8-4 to try and do it in one day. I mean, I could have, but you would have hated me.
Could have, should have.
You end with X plus 1 all over 2. Okay? For your Y value. Now, the process for these, when we're doing the work with logarithms, it doesn't change when you flip-flop to solve for inverses. Okay? It still does the same thing. So if I'm starting with the Y equals the log of base 3 of X, there's a fraction bar and there's a caret bar.
He's taking the test.
I was just trying to make it seem like it was tougher than it was. There.
You didn't tell him what equals. Answer's Q.
And then in this case, what's the how do you rewrite that to get Y by itself? Yeah, that's all it is. So this winds up being 3 to the X is Y. And that's it.
Where's the trick?
There isn't.
Wait, how did, why is it that?
I'm sorry, what was that?
How
This is
Explain it.
log base 3 of Y. Okay. When you go to your rule,
Oh, wait.
the base is raised to what it's equal to. Y is by itself. Watch what happens. Do it again the next one. Exchange X and Y. And now the rule of the logarithm is 9 to the X is Y. Have you noticed a pattern here?
No.
Yeah,
They're almost.
it's literally the same thing as doing exponential.
They're all log complement.
He gets it.
Exponential form? That was a good one.
That's really good. 9 to the X, 3 to the X.
Oh.
What do you think this is going to be? Oh, this one's trickier though.
Oh,
See,
wait,
that
now,
was
now
my-
there's a pattern
What
that
did I
changes.
do?
That would be 2.
Where's the friendship
It's
in
gonna be
that?
log.
In this case here,
7.
when you change, before you do anything, you can simplify that. Simplify your bases. Everybody okay with that? So now what's log base 7 to 7 to the 2x?
2x.
2x. So now you wind up with y equals 2x. Flip-flop your x and y. So x over 2 is y. And that's it. The idea here is when you start to see these inverse functions, if they're writing them out to you in terms of y equals log base 5 of x, the shortcut for this, the inverse of that value, is always 5 to the x is y. Works every time. The only caveat is when you have that, where you have a logarithm you can simplify with the exponent. That's the only thing you gotta watch for. And those, as we've seen, really aren't that bad. Wait a second. Okay? Those should not be very bad. You're not buying it. Why are you being skeptical?
Because I know you're going to bring out something that's going to make us
No? I'm not lying. So far, nobody's gotten mad at you for this stuff today, which is a rarity by 12th hour. Usually, usually you can tell when people are mad.
We're brother back in 14th class.
Real fast, I want to talk about what's called the natural log.
How you sneeze.
Natural log, and this really, you don't have to write all this out. E comes back here. what happens here, if you have a log with the base e to the x, this equals natural log. What's that?
I posted a picture of it on Instagram and tagged Chloe.
The tree.
What? The word hurt.
Anyway, what I'm talking about here is that when we get into some of the inverse things, you do have to deal with e and natural log. They kind of undo one another.
Wait, does that say 1nx or what?
ln, it's an ln, yeah. Natural log is what that's it.
Capital L?
If you want, that's fine.
Okay.
Your calculator has a button that says ln, it's natural log.
Why is it LN instead of NL? Why is it natural log?
I don't know. You're using natural logs when you have a e as your base of the log, okay? It's more of a scientific thing that you see a lot more when you have exponential growth decay style problems. It's things that you will see. It's not that you're developing the proof or anything how it works, it's just one of those things, okay? So what I'm getting at here is, how would you undo natural log? You e it. How do you undo e? You natural log it. It's basically what you're looking at, okay? So if I'm looking at this and I wanted to do the inverse again, if I want to do the inverse of y equals the natural log of parentheses x plus 1, first thing I do is still switch my x's and y. And then to undo natural log, you e it. And by e it, it's that exponentiate word I made up yesterday.
So this stuff is calculator part of the class,
No, this would be non-calculator, because you don't have to use calculator to do this.
but E.
You're just using a letter.
Oh.
Watch what happens.
So wait, so it's all done to the power. What's my e to the x?
Guys, please stop. One person at a time. What was that, Olivia? What was that?
Is it so like are those is x and l y are those exponents now?
They're exponents. The way that I'm writing this out to show that I'm exponentiating, I'm putting them as an exponent. So these two undo one another. This drops. You get e to the x is y plus 1. How do you get y by itself then? You subtract 1. Yeah, Molly.
Wait, is e raised to the y plus 1 or like?
E to the natural log of y plus 1. This is a new exponent. I exponentiated it, if you will. I made it an exponent by putting e as the base on both sides. E as a base, natural log as its exponent, undoes one another. It allows the rest of the junk to fall. That's all it does.
So e to the x minus 1 is y?
Yep. Notice the minus 1 isn't in the exponent. Okay? The x minus 1, the minus 1 is not part of the exponent.
Is there like math kit where you have to put -1 first, or is that?
No, you can leave it like that. I think the book will put -1 plus e to the x. I think they'll do that just to alleviate the not thinking they go in the exponent, but it's not that big of a deal. All right. One of the yeah.
So the ln x. Oh,
No, the ln is the natural log.
yeah.
Yeah, the exponent. I thought you said just x. I didn't hear the exponent part. Yes, the natural log becomes an exponent by putting e below it.
Which is the x.
Well, that's the same as saying e to the log e, right?
It isn't the x.
They're not identical.
This is
What's these two values undo one another.
okay.
So there's
When those two values undo each other, whatever's left just drops out.
So you put the e on both sides.
Yep,
Okay,
keep it.
I got it.
Inverse. That's what you do.
So I have like
No, it's not like that other one where we had that base 7 or 49. That one I did that first before I switched it because I saw, I can't do anything until I fix that. Okay. Same idea here.
So LN is the same as log e. So it's saying e is the log e, and that's why they cancel out?
Exactly what it's saying.
Okay, that makes sense.
Here, switch it. What do you have to do first? All right, after I do that.
Make it e.
Can I e it first, or do I have to move the 3?
Minus e.
I gotta move the 3 this time, because this is not tacked in with parentheses. It's not part of the natural log. The only thing that has the natural log right now is y. That's the difference between these two problems. There's no parentheses in this one. So now you move the 3 over, you get x minus 3 is the natural log of y. Now you e it. When you exponentiate both of these, e to the natural log of y becomes y. And this is just e to the x minus 3. And that stays up the exponent. Okay? And what Clay was saying here a second ago was when you have natural log is log base e. So when you have log base e to the e, that's why these drop out and you're left with that. That's what's happening. Right? That's what's happening. Right? Those are the only two different types of things you're going to see with doing inverses. Inverse of natural log, you e it. When you had the other ones, you just kind of flip-flopping your exponents. Okay? You just flip-flopping those around, and it'll work nice and clean. Right? The more important of these inverse things is literally in 2 sections when you have to solve equations. In order to get exponents to fall, you have to be able to do these little tricks. That's where we're heading towards. Once you see a couple of those later on, it's going to be, oh, this is nothing. Because you're doing the same thing on both sides each time. Okay. Works out real clean. Which leads us to graphing.
Yay!
Okay? When we get into graphing, you'll be surprised at how easy this is.
What page is that?
You always say that,
Okay.
and I'm surprised at how wrong you are.
Have a little bit of faith. Get a smidge of faith for me today. This
I
is-
do every day when you tell us something is easy and then it's not.
Yes, ma'am.
Do you get to use calculator?
No. You don't need a calculator for log graphing because you only need to get 2 ordered pairs.
Yeah, that's also.
Okay? So here's what
Oh,
happens.
and then everyone falls.
When you have logarithm graphs, you've got log base b of x minus h plus k. Yes, sir.
Why in all of the equations that we learned from graphing, why is it always minus h?
Because that's the way they write them out. Because it's the opposite of h to get you your what do you want to call it? Your shift, if you will, or where it's going to the vertex.
Oh, like why not just plus h?
Because that's what.
Because math.
Because the distance formula,
Come on, George.
farthest minus the closer.
Okay, I guess.
That's why I press it. So you wind up with your h and k again, but this is the one instance that you do not need to do a parent graph. All right, so it makes it a little bit easier. When you're working with this one, your line of x equals h is your vertical asymptote. Your domain is always going to be to the right of it. Your domain will always be x is greater than whatever your h value is. Your range is always going to be all real numbers. And your graphs can only go in one of 2 directions. If the value of your base is greater than 1, it's moving up and right. If your value of your base is between 1 and 0, it's moving down and right. That's all that can happen. Because you're never going to have a negative base. Logarithms don't have negative bases. That's one of the rules. Because the rule for logarithms is that your base is between 0 and 1. It doesn't go any less than 0.
So what is it if it's less than 0?
It's not less than the
Oh. Yes, we'll say that.
It's like,
It's imaginary log.
Oh, wait,
does that happen?
I don't know.
just to clarify,
Does that actually
that's
happen?
between 0 and 1, right?
Yes.
Is that the newest product, the iLog?
So, I log.
I
All they give you.
Okay. So when you go through these, when you're going through these things, guys, you've only got to come up with 2 ordered pairs. You're only going to come up with 2 sets of ordered pairs. And the ordered pairs you come up with rely upon the the 2 rules of log base b of 1 equaling 0 and the log base b of b equaling 1. What you're going to do is manipulate the values of x to create a logarithm that gives you these. It looks weird at first, but once you do this a couple of times, you're going to say, oh, that's pretty easy. Trust me, okay?
You broke it, my brother.
I know I broke your trust, but I'm going to try and earn a smidge back.
Good luck.
Thank you. So let's look at this one. We have y equals log base 1/3 of x minus 1. All right. When I start log problems, I list everything. They would let me write on the board. What's your base?
It's 1/3.
1/3. What's my h?
1.
It's 0.
Oh.
Is there parentheses?
No.
That means your h value is 0.
Oh.
The x minus h will always be in parentheses. If you don't see parentheses, your h value is always 0.
I just thought there was no K.
My k value is -1. So with h being 0, where's your vertical asymptote?
0.
So my asymptote is at x equals 0. What's my domain?
All real. No. Sorry.
Greater than.
It's greater than 0.
Range is all
X is greater than 0.
X is greater than, I wrote 2 for some reason. My range is going to be all real. So
What is sign on?
when I do these problems, I like to knock all that out right away. Because now there's one other thing that I can tell from the information I'm getting.
Which was
The direction of the graph. It's going that way. You okay with that?
Yeah.
It's swooping this way. So when you're plotting these out, do that little sketch next to where your b value is, so that way you know when you go to plot your graph, if it's not matching up, you've gone and done something wrong. Okay? You okay,
You
so?
go on the right one, maybe, or something else.
Unless you turn around and you're going the left.
No, you're not.
Wasn't even funny.
I know. I try though. There's my vertical asymptote at x equals 0. Notice I labeled it. Now I need to figure out ordered pairs. And this is where it gets weird. What I want to do is I want to use my log rules. I want to pick a value of x here that makes it easy to use. 0. If I use 0, if I use 1, it's getting ahead of myself. If I use log base 1/3 of 1, what do you get? You get 0. Log base 1/3 of 1. Doing your order of operations, this value here equals what? 0. And what's 0 minus 1? -1. So my first ordered pair would be at 1, -1. Log base b of 1 is 0. This is kind of these two rules are very important for this section. Okay. Log base 1/3 of 1 is 0, because 1/3 to the 0 power is 1. I'm using those properties. Okay. I'm going to do the same idea. I want to pick a value of x that is the same as my base. So I'm going to pick, what's my base? So what am I going to pick here? 1/3. So my other ordered pair would be at, this over here, log base 1/3 of 1/3, and then I subtract 1 from that.
So 0.
So you get 0 of that. So the other ordered pair is at 1/3, comma, 0.
And this works the same way for every problem.
Yes. You're picking these guys because these are the really only 2 clean points you're going to get. Everything else winds up being awful decimals.
So we use each equation once for the order pairs?
Yes. Yeah, you're going to figure out these two values. Yes.
Like subtracting 1 because it's different from the other part?
Yes.
Or because you need to make that the same?
I'm subtracting 1 because there's a k value. I'm doing this part first. Right. Because log base 1/3 of 1/3 is 1. 1 minus 1 is 0.
Oh,
Does that make sense?
yeah.
What I'm doing here is I'm simplifying, I'm doing my order box, I'm doing this logarithm's an exponent. I'm doing this part first before I subtract the 1. Okay? So your 2 ordered pairs were at 1, -1, and 1/3 and 0. Is that matching the curve idea of what I've sketched to begin with?
Yes.
Connect the dots. That's all I gotta do. You could pick out other values because what is 1/3 power? Third root, right? So I could pick 8 for an x value. And you can go on if you want, but that's just silly. We use these 2 points. Yes, sir.
Isn't like logarithm just the same form as the exponential form? It's just like it's changed?
It's all it is.
Why do we get a vertical asymptote here and then a horizontal asymptote when we're doing like the growth and stuff with those?
When you have, it deals with the base when you're dealing with the logs. I know that they're equivalent in form, okay? It's just the way that you rewrite it through. Now, if you have b to the x equaling y versus b to log base b of y equaling x, in order to graph that, you have to get in y equals form, which means you have to invert the whole thing to go around it. So you're getting, when you graph it, you're getting the inverse function. B to the x equals y is the inverse of log base b of y equals x. So these two mirror itself out. So the actual inverse of this will be coming around the other way, and they'd be they'd be symmetrical along a vertical line. Yes. Or sorry, they'd be along a diagonal.
Yeah, okay.
Yes, ma'am. Sorry, she was like that.
Oh, sorry. So wait, are these like, is there not a shelf or are these in the or?
No, we're doing parent or we're doing this built into. This is everything. This is all there is to it. There's no extra. There's no. Once you get these 2 points, you're done.
So then with undergrads, there's a condition.
Yeah, those are a little bit different. Yes, sir.
The log 1/3, what did that make it to get you to 0 for the y value?
Log base b of b is 1. Log of 1/3 of 1/3 is 1. 1 minus 1 is?
0.
There you go. Let me show you the different version.
I really don't think I need this correct.
The difference between this one and the one we just did is that this one has an h value. Notice how there's an h because it's in parentheses?
Yeah.
So this one you do just a little bit more work with because you have to create these values. So you've got log base 5 of the quantity x plus 2. Start by labeling out everything you know. Stop playing Nancy's. Your base is 5. Your h is?
-2.
Good, -2. K value? 0. So that means my vertical asymptote is at -2. My domain,
X is greater than -2.
x is greater than -2, very good. And range, all real. What direction will my graph be going? It's going to do that. What? Okay. Line terrible. Go put it in your graph now. You plot your axis. Vertical asymptote at -2. Now I want to create my ordered pairs. Notice, since we have an h value, we are going to use that h value to figure that out. I want the log base 5. I want that whatever's in parentheses to wind up to equaling 1.
Three.
-1.
-1. I want to use, I'm doing the first one, you're ahead of me. All right, I want to make that parentheses equal to 1. So what does x have to be? -1. So if my x value there is -1, what is log base 5 of 1? 0. So now that means my other ordered pair then, my first ordered pair is at -1 and 0. We okay with that? The second ordered pair, I want to get my parentheses to equal my base. What does that x value have to be? 3. I want it to wind up equaling 1, so that has to be a 3. Does that make sense? I'm creating that parenthesis to get these two properties to hold true to get my corresponding y values, because they're clean numbers. So now I have log base 5 of 5, which is 1. So this ordered pair is at 3 and 1. Those are the only 2 points you got to get me. -1 and 0. 3 and 1. Hopefully it's matching the curve that we were looking at to begin with, and it is. And there you go. Yes, ma'am?
Will we ever get a curve that is to the left of the asymptote?
No. Logarithms are only going to the right. They only go to the right of the asymptote. We're only going to go to the right of the asymptote. Okay?
Do algorithms, because that's a word that has id.
Algorithm is like how you, a process of what you do something.
Okay, because it has id in it. I've always wondered if it's related.
No, algorithm is like PEMDAS. Please excuse my grammar, Sally. It's an algorithm to solve a problem.
Okay.
Not that scary, I'm hoping, right?
No.
He's gonna make it scary.
Let's just say one word.
It's going to be like Australia. I'm guessing 30%.
Oh, it's a practice. It's a practice.
Take a minute. Take a minute and do this one. Yes, please. Remember, I can't stress the importance enough of labeling out everything. B value is 1/2. Is it going up or is it going down?
Down.
It's going to go like that. All right. Now, when you go, you know your domain, x is greater than 2. Your range is all real. You get that far, the rest of it shouldn't be horrible. Start. Put in your vertical asymptote. It's at x equals 2. All right. I know that's where that's going to go. My 2 ordered pairs I have to worry about. I want to take my log of base 1/2 parentheses minus 2, and then I add on the 1. I need this first part. I want it to equal 1 in the parentheses. What do I choose for x? 3. So log base 1/2 of 1 is equal to what? 0. So this first chunk becomes 0. 0 plus 1 is So my ordered pair is at 3. This is really annoying. 3 and 1. Okay with that? That's my first ordered pair. I do the same thing to get the same base. So I want log base 1/2 parentheses something minus 2 plus 1. What do I put in for that value of x to make the parentheses equal to 1/2? 2.5. So log base 1/2 of 1/2 is 1. What's 1 plus 1? 2. So my ordered pair here is 2.5 and 2. When we plot it, we had 3 and 1, 2.5, and 2. Is that mirroring the idea that it's working downward? And you're done. Yes, ma'am?
So K is just the shift.
Okay, it's just a shift. You're worried about the log part first. You're worried about what's in the parentheses. Guys, I'm done with it. People around you might want to pay attention. You're worried about this first portion of it to start out with. When we have the other one where we were just plus it's just a k with non-parentheses, you were just looking at that to go. Here, your value of x was just going to be 1 and 1/3. When we started putting parentheses around it, we were creating that parentheses to be a 5. We were creating that parentheses to be 1. That's how you adjust your values of x. That's why you don't need a calculator. Question? Let me give you a few of these to try out. Grab which number is it? It's the next page over, so it's what, 491?
Yeah.
Got a couple inverses and a couple of the other ones, so it's 491, same section.
All correctly?
No, there's a couple inverse also. I want you to get 56 and 62, and then it's 65 through 75 for the graphings, okay? Odds.
We're going to grab all those.
Just those, yes, there's 4 of them.
Wait.
There's 5.
There might be 6, but whatever.
No, I just let you take half and add one.
All right.
Take the difference and add.
The first 2 are inverses, the last 6 are the graphs. When you're graphing them, do them just like we did in class. What's up? Any other questions on that?